So let's go ahead and use those properties of an isosceles triangle. Now, with this figure, you might say, Mr. Cooley, I don't see an isosceles triangle. Well, what I'm talking about is let's break this up. So I'm going to break it up into two different pieces here. Again, we don't know much about quadrilaterals yet. So let's instead just draw out one isosceles triangle, the top one here. Okay. And we'll draw out the second one as well. Great. Now, for some of you, this might be unnecessary, but I'm trying to illustrate a technique, and that is, again, if you have a complicated figure, just break it into simpler figures, and of course, you can always refer back to your original figure. So let's go ahead and mark up these diagrams with that main property that we know about isosceles triangle, and that is if we have these two congruent legs here making an isosceles, then the base angles, or the angles opposite those congruent sides, must also be congruent to each other, which means this is worth y degrees there as well. And I'm going to do the same thing for the other one while I'm at it. Now, of course, we could mark up our original diagram as well. In this problem, I'm going to hold off on that. It's actually not going to be necessary. And why do the extra work if we don't need to? And now I'm going to use the fact that I know that if I add up all three angles of a triangle, they add up to 180 degrees, and hope that I can solve from there. So the three angles here, I'm going to add those up and set them equal to 180 degrees. And hopefully you see that is definitely something that we can solve. All right, so I've got that y equals 50, and I'm going to do the same thing for the second figure here. Add up all three angles and set them equal to 180 degrees. And now I've found that value as well. Again, I usually like to plug them in here just to make sure, yep, that seems to make sense. And plugging it into this equation as well, or this drawing as well, I get 50 degrees there, 50 degrees there. Yeah, everything seems to line up real nice. I could, of course, plug it into this drawing as well. I oriented everything the same way, so it's pretty easy. And one of the things that's nice about this is if we wanted to, we could go ahead and verify that all of the angles here add up to 360 degrees. Since this right here represents one angle of our quadrilateral and this represents another angle of our quadrilateral, we have 90 degrees here, 90 degrees here. That's 180 plus 180. They do total up to 360 degrees. And that is what we know the interior angles of a quadrilateral must sum up to. So again, another quick check to make sure all of our shapes actually make sense in, frankly, the real world. But again, the main part of this video was just to illustrate the fact that if we do have a complex figure that we can break up into simpler figures, that's usually going to be a nice technique to help us solve complex problems.